Step number 7. So find the entering variable, that is key column. So we are choosing the most negative value. Fine. If any one most negative value is there, that becomes the entering variable. Or if any two values having the most negative with the same values, so choose any arbitrary value. So if all xi are less than or equal to 0, then there is unbounded solution. Whereas if at least one xir is greater than 0, then corresponding vector enters the basis. Then we will go for step number 8. In this step number 8, we will find the leading variable, that is key row. Here we are finding key column, we are finding here key row. Fine. So compute the ratio. Compute the ratio x bi divided by x kr. So we need to compute this ratio. Find the minimum. Find the minimum ratio. Find the minimum ratio. Then choose the variable. Then choose the variable xk to leave the basis, called as leaving variable, which is called as leading variable, or key row, called as key row. Find the element at intersection of key row and key column is called key element. Is called key element. Fine. This is step number 8. Second, I will repeat step number 8. Compute the ratio of xbi divided by xkr. So find the minimum ratio. Then choose the variable, that is xk, which has the minimum ratio, as a leading variable, called as leading variable. I mean to say, to leave the basis. Choose the minimum xk value as a leading variable and is called as key row. Next, the element which we got by the intersection of key row and key column is called as key element. Right? So, in the step number continuation of this step, fine. In the step number 9, what happens? Form a new basis. Form a new basis by dropping leading variable. By dropping a leading variable and introducing entering variable by introducing entering variable in the basis. Fine. So convert the leading element. Convert the leading element by using the formula. Formula that is new. Let me write once again here. That is new element is equal to old element minus product of elements in key row and key column divided by key element. Divided by key element. Fine. Let me explain this step number 9. So form a new basis. I mean to say form a new simplex table that is called as new basis by dropping the leading variable and pushing the entering variable in the basis. Fine. Convert the leading element by using the formula. So new elements has to be calculated. So those values of those elements will be calculated by using this formula. That is new element is equal to old element minus product of elements in key row and key column divided by key element. Fine. This is the formula. Fine. So the next step is step number 10, which is the last step. Fine. Go to step 6 and repeat the procedure until an optimum solution or an indication of unbounded solution. So after step number 9, getting the new element, again go to step number 6 and repeat the procedure until we got an optimum solution or there is an indication of unbounded solution. So there are totally 10 steps. So let me repeat, there are totally 10 steps. In step number 1, we check the objective function. If the objective function is minimization, then convert it into maximization. And in step number 2, we will check all the BIs. If any BI or more than one BI are negative, then we multiply by the negative sign for that particular constraint, so that negative BI will get converted to positive. Then in step number 3, we will express the given objective function in a standard form by introducing slack and surplus variables. Fine. So then we add artificial variables to the constraints, so to get the identity matrix. So in step number 5, the given problem is formulated in a simplex table. Then in step number 6, we compute Zz minus Cj. So we will check whether the Zj minus Cj is positive or negative. If Zj minus Cj is positive, we got initial basic feasible solution. If Zj minus Cj is less than 0, then we will choose the most negative Zj minus Cj value. Fine. Whereas in step number 7, we find out the entering variable, and in step number 8, we are finding the leaving variable. The intersection of entering variable, that is key column, and the intersection of leaving variable, that is key row, we will get a key element. Fine. So using that key element, we are supposed to find the new element with the formula. So once we got the new element, again we are going to go to the step number 6 and repeat the procedure until we got optimum solution or indication of unbounded solution. Fine. Thank you.